Good day to you, students. I hope you guys are doing fine in your various homes. In our last class, we discussed acid-base equilibrium, which we use in capping ionic equilibrium. Today, we are looking at a very important new topic titled water. Right from when we were young, this is a substance that all students and both living things and non-living things are always used to. Right from even when you are a fetus, in the course of developing or growing from one stage to another, you cannot do without water. But it is very good for us to identify the importance of this water. And due to the importance of water, water is considered to be life itself. Because without water, there is no way our life can be sustained. Now, let us quickly look at some certain things about water. Just like I said the other time, that water itself is life because it is very important and the most abundant substance on the earth's crust. And apart from that, if you look at the animals, we discover that 60% of the component present in animals is made up of water. The same thing is also applicable to the plants. All right, let's quickly look at the various sources of water. We have different sources of water, and these sources can be divided into two. We have the natural sources of water, and we also have the treated water. We are going to discuss this one after the other. Let's quickly look at the natural sources of water. There are various sources of water found, when you say natural sources of water, these are the various sources of water found on the Earth's surface. What are examples of this? Your rainwater, the spring water, lake water, river water, sea water, and the likes. And among all these natural sources of water we have mentioned, rainwater seems to be the purest of them all. Why? This is simply because it is obtained from the process of evaporation and condensation. That is, water is converted to vapor, then vapor returns back to water itself. All right? But mind you, we have some geographers that will always claim that spring water is purer than rainwater. But mind you, spring water contains some certain level of impurities, even with the presence of some level of bacteria. So that is why spring water is not considered to be the purest among all the natural sources of water. Now let's quickly look at the treated water. You don't treat water without a purpose. There's always a specific reason why we treat our water. And what are examples of this treated water? We have the distilled water. Distilled water is this common water we use in the laboratory to carry out our analysis because it is free from impurities. And this distilled water is gotten from evaporation and condensation. And that is why rainwater is also referred to as natural distilled water. We said it, water is usually treated for special purposes. Examples are distilled water, which we have just discussed here. Then the next one is deionized water. When you say deionized water, it means the water whose all forms of ions have been removed. Let us take, for instance, iron is not, a high proportion of iron is not too good for the body. So if you want to remove this from your water, that means you are deionizing the water. Such water is called deionized water. You can also have ionized water as well. That is a type of water, in which probably you have added some certain level of ions, which is required in a specific nutrient. Take, for instance, calcium is responsible for development of bones. You can add this to your water if it is not in abundance. Then another one is pipe-borne water. This is the water that is treated for municipal supply, for township. And the last one is chlorinated water, which is gotten from treating water with the help of chlorine. And don't forget, the basic function of chlorine in our water is to kill the germs. Chlorine has no other function it performs apart from killing all forms of germs, so that it makes the water free from all forms of diseases. Now, let's quickly look at the structure of water. All right, water is gotten. Don't forget, before now we have discussed types of bonding, covalent bonding and electrovalent bonding. Water is one of those examples of compound gotten from covalent bonding. And this is obtained when you have two atoms of hydrogen covalently bonded with one atom of oxygen. And there's a particular principle involved in this. It involves sharing of electrons. We will quickly look at what is happening here. During the formation of a covalent molecule of water, each of the hydrogen atoms, don't forget you have two hydrogen atoms there, each of them will donate one electron, while oxygen atom donates 2 electrons, so that it obeys octet rule. Then the electrons donated are now shared between hydrogen atoms and oxygen atoms. Now let's quickly look at how you draw the cross and dot diagram of this explanation we have said here. That's one of the high GCSE questions anyways. Okay? Now, this is 2 atoms of hydrogen. We want to see the dot and cross structure of how water molecule is formed. This hydrogen is having 1 electron. This is, if you want to draw this, it becomes, the 1 electron is what we have drawn here. Then hydrogen here, another hydrogen atom is having 1 electron. The 1 electron is what we draw here. Then inside this place you have the nucleus plus 1 atom of oxygen. Oxygen is having an atomic number of 8. The electron configuration is 2, 6. So that means the outermost electron will be 6. So let's draw the electronic structure of this. 1. We are not going to use the same symbol. This is a dot, while we use cross for this. That's 2. Then the next one is 6. 1, 2, 3, 4, 5, 6. You have 6 electrons there. This one will now give us. Now, what is happening here is that since they are sharing the electrons they have donated, this one will donate its electron, this one will donate its electron, and oxygen will donate 2 electrons. These electrons will be shared with 1 electron here. This electron will be shared with 1 electron here. So it will now form something like this. This is the interior shell. Then you now have 1, 2. Don't forget this hydrogen atom structure. This is what we have here. The second one is what we have here. The electron that is donated by this hydrogen is this. Why the one that is donated by oxygen is this? The one that is donated by the second hydrogen is this. Why the one that is donated by oxygen here is this? Then don't forget, we now have 4 electrons left. So this is 1, 2, then 3, 4. If you count the number of hydrogen for, the number of electrons for hydrogen here, you now have 1, 2. It means hydrogen has obeyed duplet rule. Stable. 1, 2. That hydrogen has obeyed duplet rule. But in the case of oxygen now, oxygen needs 8 electrons. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. From there, it means that water molecule has been formed. So this is 1 molecule of water molecule. So let's quickly look at the shape of the water now. From what we have here, we can easily draw the shape of water as, this is the oxygen, then the hydrogen that is attached to it. This is it. This is the hydrogen, and this is the second hydrogen. Then on this, you have 4 electrons here. 1, 2, 3, 4. 1, 2, 3, 4. So these 4 electrons are the lone pair of electrons. Then there is a particular bond angle that is found between these 2 hydrogen atoms. That's one of the objective questions you made, probably in WAHEC and IGCSE. This angle here is 104.45 degrees. So that is the angle that is found between the 2 is 104.45 degrees. Now, this is 1 molecule of hydrogen. Then what of when you now have 2 molecules coming together? You have it like this. This is one of them. This is hydrogen. This is hydrogen. Then this hydrogen will link with another oxygen, another water molecule. This is hydrogen, this is hydrogen. This one can as well link with another water molecule, hydrogen, hydrogen. Now, the type of bond that is formed, between this hydrogen and oxygen, you call it hydrogen bond. You call it what? Hydrogen bond. And this hydrogen bond is responsible for the reason why water molecule is said to be liquid at room temperature compared to other, compounds like carbon dioxide, which is having a greater mass number, which is also in gaseous state. So this one is in liquid state, while carbon dioxide is in gaseous state. All right. So with this short video of mine, I believe I've been able to explain some certain things on this substance called water. This is just few among the many more things we are still going to discuss at the Google Classroom. So when we get to the Google Classroom, we discuss more. And as you watch this, I pray God bless you. We meet at the Google Classroom. Thank you.